Hello everyone, I hope you all are having an amazing day. So previously we actually worked on exploratory data analysis and we ended our video after generating the heat map for income and and different plans. In today's video, we will actually talk about feature engineering, especially what kind of feature we might need for our analysis, and also what kind of step-by-step process we will follow. We will see all those things in this video. So at first, let us see our data set. And in our data set, if we scroll to the right, we can see that there is a medical history column, and it contains different types of diseases for each members or for each customers. Okay, so let us check the medical history, what kind of well accounts it contains. So for that, we will use df2 and then sorry, medical history dot unique. So we can see that it has different types of diseases for each customers. Like some customers have diabetes, some have high blood pressure, some does not have any kind of diseases. But on the other hand, some has both diabetes and high blood pressure, and then high blood pressure and heart disease, and then diabetes and thyroid. So all sorts of things. So we actually need to create a risk score type column, and in this risk score, the score will be higher if the patient or if the customer contains more diseases. Okay, so if the customer contains only diabetes as his or her disease, then suppose his risk score will be like 6. But if he contains both diabetes and high blood pressure, then his or her score will increase to 10 or 12, something like that. Okay, so we need to create a risk score type column to represent this medical history properly. So for that, what we are doing, we are creating a dictionary here, and we are naming the dictionary as risk scores. And in that dictionary, what we have diabetes, and we are arbitrarily scoring each diseases. For diabetes, we scored it as 6. For heart disease, we scored it as 8. Blood pressure will be 6. Thyroid 5. No disease is 0, and none is also 0. So suppose a customer has both diabetes and high blood pressure, then his total risk score will be 6 plus 6. It will be 12, something like that. Okay, so let's just run this and create this risk score. So right now, what we actually need to do is that we need to split our medical history column into separate diseases. Okay, and for that, what we need to do is we need to split it based on this ampersand character, right? So for that, what we are doing here, so let me show you like one by one. So if we only use this code like df2 medicalhistory.str.split, and we are providing on what character the split should happen. So if we run this, then we can see only the first end of the values. Okay, so we are seeing diabetes and then high blood pressure, no disease. Okay, we are only seeing the first part. Okay, we're only seeing the first part, but we need to be able to see the second part also, like the other disease. So for that, what we will do, we will add an argument that is called expand, and we will set it as true. Then what we will have is we will have two different columns. So first column will be like the first part of the disease, and second column will be none, or it will be like any value. Okay, so what do we mean by any value? So it is showing none. So when it only contains diabetes, it only contains high blood pressure, then for the second column it is actually showing none. But when it actually has two diseases together, diabetes and high blood pressure, then it will show the second disease name on the second column. Okay, so for that, let us do a sampling. Let's just take it 15 sampling. Okay, let's take again. So you see, we get a row 29,482. So here it contained diabetes and thyroid, but after doing this kind of splitting, what we are getting, we're getting disease one at this column, and we're getting the second disease name on the second column. Okay, so this is what we are doing. And additionally, what we are doing is that we will suppose make all the letters on lowercase. So for that, what we are doing, we will have to use the apply function and also lambda function to apply the lowercase function or method to all the rows in our data. Okay, so basically what this lambda x is doing, so this lambda x is actually covering, or it is actually capturing each values. Okay, each values in both column. And what we are doing, we are saying that when you're capturing each value, make sure you also transform each value to lowercase. Okay, so this is what we are um, giving direction in this apply this lambda function. Okay, and if we run this, then you see we got um, all the things as lowercase. Okay, now now what we are doing here is that we are creating separate columns for these two columns. Okay, so we are inserting the first disease of the things in disease one, and we are also inserting the second disease of the things in the disease two. Okay, and in first disease one, if there is any NA value, then replace the NA values you with none. And in the second disease two, if there is any NA value or missing value, then replace it with none. And also we are creating a, you know, a dummy variable, total risk score, and we are putting it as 0, like we are initializing the total risk score as 0, but we will actually calculate total risk score for each diseases. Okay, so right now, what we will do, well, let's check our data frame here. We will go ahead. So if we scroll to the right, so we can see our new column, disease 1 and disease 2. Okay, diabetes none, none, something like that. Okay, and the initialization of total risk score as 000. Okay, now what we need to do is that we need to loop through each of these disease disease names, and we should calculate total risk score. Okay, so for this disease, for this row, we have diabetes, and we for disease 2 we have none, and the total risk score will be 6 plus 0 equals to 6. Okay, here it will also be 6 plus 0 equals to 6. So how we are actually doing this? So we are looping through each variable, and we are also like summing and calculating the total risk score based on our risk score dictionary that we created earlier. Okay, so here what we are doing, df to total risk score will be plus equals to, so plus equals to means we are just adding it for each iteration of our loop. We are adding the value inside this risk score. Okay, and here ODF2 disease, this is basically our iteration variable. So for each iteration or for each row, what it will do, it will map the disease with their related risk scores. Okay, and then it will keep calculating. And another thing we can do is that let us just go to chat. Okay, let's use Gemini for this. Can you kindly explain this code chart? And also what let us do is yeah, Okay, now let's run and let's see how Gemini explained this. So this code calculates the total risk score for each row in the data frame DF2 based on the presence or absence of certain diseases. And then it's at first explaining the risk score dictionary. Disease row for loop iterates over two disease columns. Is score mapping. For each disease column, the map function is applied to the corresponding values in DF. This maps the disease names to their respective risk scores from the risk scores dictionary. The map risk score are added to the existing total risk score column in DF2. This accumulates the risk scores for all diseases present in each row. Okay. So if you find a difficulty understanding my explanation, what you can copy the code chunks, paste it to ChatGPT or Gemini, and tell it to explain it to you. Okay, and then it will do like wonderful work on explanation. Okay, moving on. So we actually created the risk scores. So let's run this thing. Okay, and let's check the DF2 head. Now you see the total risk score, we are having values here 6, 6, 6, 0. So why it is 0? Because no disease, we actually mapped no disease risk score as 0, and none is also 0. So that is why it is 0. High blood pressure is 6, and okay, we can also do sample this. Okay, let's do it again. Okay, you see, there is like two diseases, diabetes and high blood pressure, and for that, we're having the combined risk score that is 12. Diabetes score is 6, high blood pressure score is also 6. So adding those together, we get 12 here. Okay. So now what we are doing, so it is a good practice if we normalize the risk score, okay? And we are normalizing the risk score based on the min-max scalar, okay? So what is min-max scalar? So min-max scalar is basically one of the scaling method, which actually takes the value and scale it between 0 and 1, okay? And in my course I actually discussed on min-max scalar, and then there is another scalar that is called standardization or standard scalar. So in standardization we actually scale our exact column based on standard z score, okay? But in this scenario, we are using the min-max scalar, and we are not using any predefined functions from any libraries. We are manually calculating the normalized risk score based on a min-max scalar. So here you can see the formula for. So we are actually getting out the minimum score of the total risk score from each total risk score and dividing it by the difference between maximum score and the minimum score. Okay. So now if we scroll to the right, we can have our normalized risk score. Now, if we also check our data frame, we can see that we have some very important text columns. Okay, some are ordinal categorical columns, and some are like nominal categorical column. So we actually already worked on the medical history, and from medical history we actually got normalized risk score. So what we can do, we can actually drop medical history and then disease 1, disease 2, and then total risk score, because we will use normalized risk score for our model value. But for the other, there are some straightforward categorical columns like insurance plan. So insurance plan is kind of ordinal categorical value, because it has a bronze, silver, gold, so like ordinal categories. And then income level is also another ordinal categorical value, like it has like less than 10 lakh, and then and then it has some ordinal categories. We also have some nominal categories also, like employment status, smoking status, and then BMI category, marital status, and others things. So we will handle the nominal categories later. At first, we will handle the ordinal categorical columns. So at first, what we have insurance plan, and what we are doing, we are just mapping insurance plan uh, based on uh, based on their values with a, numerical number. So what we are mapping? So we are mapping bronze as 1, we're mapping silver as 2, we're mapping gold as 3. So that's it. Similarly, for our income level, so we have these income level like less than 10 lakhs, and then another income level is 10 lakhs to 25 lakhs, and then 25 lakhs to 40 lakhs, and finally we have 40 lakhs. So we will also use the map function to manually map these values. So less than 10 lakhs is suppose our first, we are mapping it as 1, and the 10 to 25, and then 25 to 40, and greater than 40. Okay, so this is how we handle the ordinal categorical columns. But we also have our nominal columns, and what we did, so we captured all our nominal columns in a single list. So we have gender, region, marital status, BMI category, smoking status, and employment status. And what we will do, we will actually use the pd.getDummies function, and we will create a separate data frame. And in my course, when I was teaching you all about the different kinds of feature engineering techniques and methods, we actually went through the one-hot encoding method. Okay, and the one-hot encoding method, we are doing it uh, by following the getDummies function. Okay, or by implementing the getDummies function. So what it will do, it will create separate columns for each categories of these columns. Okay, so for gender, suppose we have two categories for genders, so male and female. So what pd.getMS will do, initially it will create two columns, like one column will be gender male, another column will be gender female. Okay, similarly, if we have like 4 regions, it will create 4 separate regional column. Okay, but in our statistical theory, there is a thing called, I think it's called multicollinearity, or the curse of dimensionality, or the curse of dimensionality. And in that thing, what we have to do, if we contain all the available columns in our data frame, then there happens is that independent variables themselves get correlated on a high manner. And if the independent variables get correlated on a high manner within themselves, then it creates a barrier, or it creates inaccurate machine learning model. Okay, so for that, what we actually need to do, we need to drop at least one at least one column for each categorical column. Okay, so suppose if we have gender male and gender female, so what we need to do, we need to drop at least one gender male or one gender female, like one column. Okay, because if gender male is 1, so this means like the value. So if the gender male value is 1, this means that that customer is actually a male. And if the gender male value is 0, this means that customer is actually not a male gender, it is actually a female gender. Okay, so we are actually able to get the information from a single column, and we actually do not need separate like male column and a female column for this. Okay, and for to enable the drop one column, one categorical column, we use drop first equals to true. And we are also specifying the data type as integer, because the result we will get based on a Boolean level. Okay, so it will be 1, 0, something like that. So we actually do not want the data type as Boolean. We want the data type as integer. So it actually returns us 0 and 1 instead of true and false. So after running this code chunk, so what we get, you see, for income level we get 1, 2, because we actually mapped it earlier. Let's check here. You see region southeast 0, 1, 0. So what does this zero mean? So this zero means that that specific row or that specific customer is not from southeast region, and this ones mean that that specific customer is from southeast region. And then southwest 0, 0, 0, and all other things. And then marital status unmarried 1, and unmarried 0 means he's actually married or she's actually married. BMI category obesity, overweight, underweight, and then smoking status and all other things. Okay, so everything got nicely mapped. After that, as I mentioned earlier, that we do not need the medical history, disease 1, disease 2, and then total risk score. We will actually use the normalized risk score column to represent our medical history. So for that, what we are doing, we are dropping the 4 columns. Okay. So now this is actually our final data frame. And let's quickly check the columns we have. Columns. Okay. So here we see that these are our final columns. But for a machine learning model, we know that we do not actually need all the columns always. So we need to select the most necessary columns. Okay. And this is basically the final step of feature selection. And for feature selection, what we do initially, we visualize between the columns. Okay. So we visualize we so in the backend, what we do, we create the correlation matrix, and on the front end, we visualize that correlation matrix using heat map. Okay, so here we are creating the correlation analysis for all our numerical columns, and we are saving it in CM variable. And after that, we're using the Seaborn library's heatmap function. And inside heatmap, we are inputting the CM variable, and we put the N naught equals to true. So it will show us the exact value, exact like correlation analysis value for each combination. And then for other things like x means the x-axis names, and then y-axis names that we are putting in the rotation, and we are putting it. So here, as you can see, we have our correlation analysis on a heat map. So let's check what actually this heat map showing. So heat map from the right side is actually showing the a limit for for the correlation values. So when the color is much lighter, then the value is on the higher positive side, and when the value is much darker, when the color is much darker, then the value is on a higher negative side. Okay. And from this correlation matrix, we can see that there are some high correlation, like there are actually high correlation between annual premium amount and age. Okay, that is 0.77. And I also saw another one is there is marital status unmarried, and a number of dependents. These have like a very high correlation, minus 0.84. So this actually makes sense that if you are unmarried, then the number of dependents will be much less, and compared to when you are actually married. Okay, and all sorts of stuff we actually read from this. And it is actually a bit troublesome to go through each combination of a correlation and to select each necessary or each potential columns one by one. So for that, what we actually do, we actually follow the variance inflation method, or variance inflation factor method. So what it does, it actually calculates a measure, and based on that measure, we actually have a threshold. Like if for each column the value gets over the threshold, then we drop that column. Okay, so let's actually go through this thing and we figure this out. But before variance inflation factor, what we need to do, we need to actually separate our data frame based on independent columns and then dependent columns, or like, um, we are separating like X and Y's. Okay. So the X is actually all the columns just apart from our dependent variable, that is annual premium amount, and Y is actually our and the dependent variable, that is annual premium amount. And what we are doing, we are implementing again the min-max scalar on our independent variables like age, number of dependents, income level, income in lakhs, and then insurance plan. Okay. And this time we're implementing the min-max scalar by using a library, scalar.preprocessing, and we're importing the min-max scalar class. Okay. And initially what we are doing, we are saving the min-max scalar class in a variable called scalar, and then by using scalar.fit transform, we are transforming only these variables. Okay. And when we use x.describe, we can see that all those variables, like all these variables, uh, those actually got transformed to 0 and 1. Okay. So for age, you can see the minimum value is 0, maximum value is 1, for number of dependents, for income level, and all other things. Okay. So scaling is a must before implementing variance inflation factor. And for the variance inflation factor, what we need to do, so we need to actually get variance inflation factor function from this library. So mainly from stats model, and then inside stats model there is a module called stats, and inside stats there is a module called outliers influence. Okay, from that we are importing the variance inflation factor function, and here we are creating a manual function. This is called calculate VIF, and in that function what we are doing, we will input our data frame. Okay. And then we will create a demo or data frame, and inside the demo data frame we will create a column named column, and it will contain all the column names of our data frame that we will actually input. And then what we are doing, we will calculate variance inflation factor for each variables from our data frame that we will actually input in this function. And how we are actually doing the loop is that so we are using the variance inflation factor function, and then we are using the data.values comma I. Okay. So this data.values means actually the values inside the data frame, and a comma I is actually going to indicate on each variables. Okay. And we need to loop through each variables, and for that we are using a for loop for I in range data dot shape 1. Okay. So data dot shape 1 means it will actually start from beginning to the last column. Okay. So what this actually means is that when we use df4 dot shape, we run this. So at 0 we get the number of rows, and at 1 we get the number of columns. So we get the number of columns. So what I am looping through is I am looping through starting from in range 19. So it will start from 0 until 19. So it will actually calculate the variance inflation factor for each variables. Okay. So this is our manual function we created, and now what we are doing, we are inputting our X data frame, that is our all the independent variables data frame, and now we will see all the column names and their associated VIF values. Okay, so looks good. But I actually mentioned about a threshold. So for the VIF, if the VIF score is over 10, then this is actually a red flag. So when the VIF score is above 10, so we need to actually drop either of the column. So here we can see for income level, we got like more than 10, and for income lakhs, we also got more than 10. But for income level, we got the highest value. So we decide to drop off the income level column, and then we will calculate the VIF again. So we are calculating the VIF, but we are dropping the income level. So now you see all our VIF values is actually below 5, below 10. Okay. So this means we are actually like we actually got a green signal to use all our variables while we train our model. Okay. And what we are doing, we are creating a separate independent variables and data frame, and we are naming it X reduced. And in X reduced, we are containing all our columns except income level. That's it. So this is the feature engineering section of our end-to-end project. And I hope you understood all the steps we actually went through in this video. But if you have any question, please feel free to drop them in the comment section, and I will try my best to answer those questions. Thank you very much, and see you in the next episode.